multiplying fractions. So quite different than adding and subtracting because we don't need a common denominator. And overall, students like the multiplication a lot more than they do adding and subtracting. And to be honest with you, you're going to use the multiplication a lot more down the road than you will with your adding and your subtracting of a fraction. So things that we want to keep in mind is we're going to hear this phrase of cross division, which is also known as cross simplifying. So we really want to understand what that word simplifying means with our particular fractions. And so let's just take a little trip down memory lane. If we have something like 2/4, and we're being asked to simplify this fraction. When we simplify, we're just trying to divide both the numbers by someone. So, for example, we can divide both of these numbers by 2. And so when we do that, 2 divided by 2 is 1. 4 divided by 2 is 2. We have a simplified fractions. 2/4 is the exact same as 1/2. All right, we have a group of 4, and you put 2 to one side, 2 to the other side. You've broken them in half. Well, that's the idea behind this. If you've got a group of 2 and you put 1 to one side, you put 1 to the other side, again, you've broken them in half. So these are what we call equivalent fractions. 2/4 is the exact same as 1/2. It's just that 1/2 is the simplified form. So we see something that's straightforward like that. We also see someone that's more on the lines here, 8/12, where we can be like, well, I could divide them both by 2, but there's actually a bigger number. So let's look at this here. If we divide by 2, which is fine, 8 divided by 2, 4, 12 divided by 2, 6. What we have to recognize here is, wait a second, I can divide both of those by 2. And then so we can do that again. So yeah, simplifying sometimes takes more than one step. Now, the other option is if we go back to where we began, is if we can find the largest number to divide by, we can get done faster. And in this case, we can divide them both by 4. 8 divided by 4, there's my 2. 12 divided by 4, there's my 3. Hey, it's the exact same answer we're looking at. So we call this the greatest common factor. And the thing about it is you don't really need to find the greatest common one. You just want to be aware that there might be a larger number that's out there. So finding something to divide by is all that's important. Just realize it might not be one and done. If you start with a low number, like 2, there might be an opportunity where you can divide again. In other words, you can simplify again. So let me throw 2 of them at you to see if you can simplify your fractions, and let's see what you come up with. Try that one. Remember to pause. Okay, what'd you divide by? 3. Yeah, in this case, we can divide them both by 3. And don't always like, oh, is there someone bigger? Is there someone bigger? No, if you find someone, use it. We don't want you sitting there and, no, think about it, kind of like the 3-second rule. Give it 3 seconds. If not, use the ones you come up with. 12 divided by 3 is a 4. 15 divided by 3 is a 5. And now the benefit is I've got smaller numbers. And I can check to see. 4, no one to divide by there. So that's also one of the benefits of just using a number is it makes the number smaller, and that can help you better find it there. So don't be kind of struggling. So, for example, someone like this, 1836. See if you can do it. And remember, it's probably going to take multiple times. Okay, I could use 2 right away, and I could divide them both by 2, and that's fine. I could divide them both by 6, and I could get started there. I could divide them both by 9, and I could start there. It just depends on what you ended up seeing. Now, I always don't want to rely on the 2 because, cutting numbers in half, well, if it helps you out, that's fine. If that's your technique, run with it. But a lot of students have a tough time cutting 36 in half. They're not as familiar with it. So the number that came up in my head was using the number 6. So I'm going to use 6. Now, if you didn't use it, it's fine. 18 divided by 6 is 3. 36 divided by 6 is 6. And then I recognize, oh, wait a second, 3/6, that's the same as 1/2. Now, I can recognize it because 3 is exactly half of 6. I can also see that I can divide them both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Hey, there's my 1/2. So if you use a 9 at the beginning, you would just use a 2 after that. If you used the 2 at the beginning, well, then maybe you ended up using a 3 and then another 3. There's lots of combinations you can use that would get you all the way down to 1/2. The greatest common factor was 18. Yeah, we can do 18 times 2 and get to 36. Now, again, we're not always going to remember that, and that's fine. All right, so let's get into the basics here of our multiplying with our fractions, because we will use this simplifying technique. So I'm going to use 3/5, and we're going to multiply it by 10/11. Okay, so the basic rules for multiplication is just multiply straight across. All right, 3 times 10, 30. All right, 5 times 11, 55. But we have to watch for simplifying here now. Now, the issue here is our numbers get large if we just multiply straight across. And it's okay. These numbers end in 0 and 5. Then we can divide them both by 5 here. 30 divided by 5, 6. 55 divided by 5, 11. Hey, 6 11s. I got there. But there's a technique you're going to make a lot of use out of that we want to be aware of. We're going to go back to the beginning of the problem. We're going to use something that's called cross division, also known as cross simplifying. And when we simplify a fraction, typically we're just simplifying the numbers that are straight up and down. So the 30 is on top of the 55. But what's also legal in a multiplication problem is that you can also look at the diagonals and see if you can do any simplifying. So for example, I can look at the 3 and the 11. Well, there's no one to divide with there. There's no one to simplify by. But check out the 5 and 10. You can divide both of those numbers by a 5. Watch. And we can do it right in the problem. 5 divided by 5 is a 1. So we cross out the original number and we replace it with the new one. So the key though is whatever you divide by, you have to divide it to both of them. So because I divide by 5, I have to divide by 5 again. And what's 10 divided by 5? Yeah, 2. Now let's multiply across. 3 times 2, hello, 6. 1 times 11, hi there, 11. We still get there. So I was playing with numbers like 5 and 10 rather than 30 and 55. And that's the benefit of this simplifying process, is you don't get the large numbers. You can simplify with much smaller ones that are there. Now, it's not always going to be there. So for example, if we had 3/5 and we're going to multiply it by 2 7ths. All right. I'm looking at the 2 and the 5. There's no one to divide by. I'm looking at the 3 and the 7. There's no one to divide by. And so we just multiply across. 3 times 2, 6. 5 times 7, 35. And there we are. That's it. 6/35. So again, multiplying, very basic, and multiplying across, but we've got to watch for our cross division, because in math we are always looking to simplify. Let's try another one here. How about 8/9? And let's multiply that by 1/6. All right. So first thing is looking for that cross division. And I'm looking at 9 and the 1, and there's no one to divide by. I mean, I can divide 1 by a 1, but when we divide something by a 1, it doesn't change the number. So yeah, nothing's going to work there. Look at the 8 and the 6 though. Who can you divide by? Yeah, a 2. You can divide both those numbers by a 2. So 8 divided by a 2, 4. 6 divided by 2, 3. Now I can multiply across. 4 times 1, 4. 9 times 3, 27. So can't simplify there. 4 27s. I always like looking at the smaller number. 4, who can you divide by? Well, I can divide it by a 2. I can't do 27 divided by 2. The only numbers that 2 can divide with are even numbers, and 27 is an odd number that's there. But if I didn't do that, I'd have 8 times 1 is 8, and I'd have 9 times 6, which is 54, and then I'd have to divide both of these guys, and we can divide both of those by 2, and that's when we get home. But again, big numbers, small numbers. That's why we like the cross division. All right, one more problem to sneak in here, and we'll see if you can handle it there. So let's go after someone like 6/15 times, and let's use someone like 10, and then how about, let's go 10/8. All right, So again, looking on those diagonals. Pause it, see what you can do. All right, so before we had an 8 and a 6, we've got a 6 and an 8. So that's your same customer. So we wanted to see if you recognize that. We can divide both of those by 2. So 6 divided by 2, 3. 8 divided by 2, 4. Check out the 10 and the 15. Who can you divide by? Did you say 5? Yeah. So 10 divided by 5, that's a 2. 15 divided by 5, that's a 3. Now we can multiply across. 3 times 2, 6. 3 times 4, 12. Now, remember, we always have to check for simplifying at the end. And sure enough, we've got ourselves 6 12s. Yes, we can divide them both by 6, and we're going to get 1/2. And a lot of you might recognize that, ooh, 6 is half of 12, so there's your 1/2 of the amount. So, again, cross division, and the main thing is that we are dividing by the same number. All right? When we use it, we cross it out, and we take it from there. We'll see you tomorrow.